Hi, welcome to the second tutorial on how to create JavaFX applications for Android devices. In the first tutorial, we demonstrated how easy it is to have an existing JavaFX application and run it on an Android device. In this tutorial, we will have a deeper look in the build structure and in the code generation of the applications, and we will use the NetBeans IDE to show how you can easily change code and run it on a desktop, but also on an Android device. So that means that we need an IDE, and in this example we will use the NetBeans IDE. I have version 8.0.2, and because JavaFX Android is based on the Android build system, which is using Gradle, it helps a lot if we use the NetBeans Gradle plugin. So if you go to Tools, Plugins, Available Plugins, and you search for Gradle, then you see that there is a Gradle support plugin which you can install, and it will be, we accept the license and we install the plugin. So doing so will enable NetBeans to be able to inspect the project structure that's being used by Gradle, so it makes it a bit more convenient. Okay, so we are ready. The second thing that we need to install now are the JavaFX samples. At the JavaFX Bitbucket repository, we have a samples directory. So if we go to bitbucket.org/javafxports/samples, you will have a list of demo applications. For example, the multi-project application, which is the one that we're using now, shows how a JavaFX application can be created and run on desktop and Android in the same project. So we will install those samples locally. So we clone the Bitbucket repository. And this will install all the samples. One of the samples is the multi-project one. As you can see, this has a gradle W file, which is a Gradle wrapper. Executing this one will ensure that the correct version of Gradle is used. This is quite important because the Android plugin is quite strict on which version of Gradle that can be used. So just as an example, if we run Gradle W tasks, we will get a list of tasks that are available in this project. Now be aware that the first time that you execute this, and if you don't have the most recent version of Gradle yet, the one that we're using here, which is 2.2, then it might take some time because it will download Gradle and all the dependencies. Okay, so here we have a pretty long list of tasks that are available now. You can do all of them on the command line, but you can also do them in the IDE. So we will switch to NetBeans now, and we will load the project there. So we open project, we're already in the samples directory. We open the project multi-project, and it will show this multi-project file, and we can already see that it contains a number of sub-projects. 3 sub-projects in the multi-project file are Android, Core, and Desktop. So Core is where we put the Java source code actually. Android contains the Android-specific code and build instructions, and Desktop contains the desktop-specific code and build instructions. So first of all, we open the Core project. This one contains a source directory with just one simple Hello Android file, which is actually the one that we used in the previous sample. So we can modify this example. For example, we don't say you clicked the button. If you click the button, but we say you click the Android button, just to show that we can easily change something. The core itself has no output, but the desktop project has some output. So if we double click on the desktop sub-project, then the project will be loaded, and we can run it in NetBeans. Running a Gradle project in NetBeans is going to call Gradle run, and this one will first compile the core, download whatever we need on top of it, and then execute the code So if we click on Hello button, it mentions you click the Android button. So this shows that we have the latest version of our code that was in the common core directory. So that was pretty easy. Now, in order to create an Android package, we click on the Android sub-project, and if you right-click that project and you go to tasks, you see all the tasks that you can execute. The one that we want to use is assemble debug, because this is the one that will create an Android package. As you could see in the previous tutorial, installing an Android package on a device is easy if you have a USB cable and if you have the developer options enabled on the Android device. So the only thing you have to do there is calling adb install and then the name of your package, and it will be installed on your device. So what is happening here? First of all, it's going to check the source code, and because we are using the same Java code which is in core, it doesn't have to recompile it because it's already up to date. And then it's doing the the Android translation things. It's compiling our bytecode to DEX code. Mind that the DEX debug step can take some time. So everything here was built in 42 seconds. Most of the time goes into the compilation of all the methods to DEX code. We can go to the Files tab in NetBeans and see what the output was of our build process. There's a build directory which contains an output directory which contains an APK directory, and you see here that we have Android debug.apk. So this is the package that's being created by NetBeans. So we didn't use any other external tool. It all works within NetBeans. So if you change the core code, which you typically want to keep in the core module, changes of this will automatically be reflected in your resulting APK. So if you want to have a look how this works on the command line, we can switch to the command line. We are in the root directory now, and you see that we have a directory core, desktop and Android. If we run gradle desktop run, sorry, gradle w, it has to be gradle w, because then we will use the correct version of gradle. Then the desktop project is called and the run task is executed on the desktop project. This is actually the same as we did before, but then from NetBeans. So that's an easy one. If we want to create the application, the Android application from the command line, we run the Android assemble debug task, and this one will create the package that we just created using NetBeans. So it's very fast, of course, because Gradle is smart enough to see that nothing has changed, so it doesn't have to recompile anything. It doesn't have to do the expensive DEX debug step. In case you have a device connected to your development system, instead of assemble debug, you can use install debug. In my case, it will fail because I don't have a device connected to this laptop. But it's as easy as just calling install debug and your application will be installed on your device. Of course, if you have a device, but I get an exception because no connected devices are detected here. So one of the good things is that you can use the same code and first run and test on desktop, and only later you can run it on Android devices. So the Gradle system is really helpful here. And if we quickly inspect the Gradle build files, we will see that the Gradle build file is in the build scripts directory. And the root build.gradle file just iterates over the sub-projects, and we'll set the repositories there to JSON, which is sort of a Maven Central repository. But the different projects each contain a build.gradle file themselves. So the core project contains a build.gradle, which tells the system to use a Java plugin, and also to use retro lambda to eliminate the lambda expressions and convert them into invoke static bytecodes. If we have a look at the source code that we were using, you see that indeed we're using a lambda expression here. So Dalvik does not understand lambda expressions, so we need to get rid of the lambda expressions and the underlying invoke dynamic bytecode before we offer them to the DEX compiler. So that's done in the build.gradle. That's done by the build.gradle file in the core project. The desktop project is a pretty simple one. It has a build.gradle as well, and it uses the application plugin, which will make sure that you can run the application. We provide the name of the main class, and we have to supply the dependencies. In our case, we have only one dependency, which is the core project. In case you have more dependencies, you can add them here. Finally, the Android project has a build.gradle file itself as well, and I would recommend that you just copy the build structure from an existing project to a new one and then modify whatever you need, because this one contains most of the things that you need in, I think, most of the JavaFX Android applications. So quickly going over it, we specify that we will use the Android Gradle plugin version 1.00, and we will take the properties from a file which is called local.properties. This file should be in the root directory of your project, and it should contain, as explained in the previous tutorial, a link to the Android SDK directory and to the Dalvik JavaFX directory. So if we go back to our terminal, you will see that there's a local.properties file in the root directory of our sample. It contains the location of the SDK dir and the location of the JavaFX dir. The SDK dir is where you put the downloaded Android SDK. The JavaFX dir is where you put the downloaded Dalvik SDK, which you download from JavaFX port. Then we apply the Android plugin, and we supply it with some compile information. Make sure to use the latest version of the build tools, or at least version 21.1.1, to increase the heap size for doing DEX compilation, not to use pre-DEX libraries on the libraries. This one this statement will make sure that we will use the native libraries, the native JavaFX Android libraries. They will automatically be packaged in your application, and the assets should also be packaged. That's another thing that you shouldn't forget. The root directory of your Android project should contain a directory called assets, and this one needs to have the JavaFX platform properties. So if we have a look at the Android directory, you see that there's indeed a directory assets, and this contains Java properties, JavaFX properties, and JavaFX platform properties. You can just copy paste them from an existing project because there's nothing platform specific in them. There's nothing application specific in them. On the platform properties, you might want to change some of the logging parameters, or you can also change the stack size in here, which is something that we can demonstrate in a future tutorial. But just make sure that these property files are in the assets directory. And then the Android project contains dependencies as well. We depend on the core module, just like the desktop module, because this is actually where our code is. And we also depend on the JavaFX jar files, which are in the Dalvik SDK. and then we need to do some trick in order to be able to support multi-dex files. In case you have a large application, it won't fit in a single dex file, but this build system will make sure that it's decomposed into different dex files, and it's going to be and the different dex files will be put in the same application in the FX activity. Finally, we have a flag that allows us to build a core library, because the well, we're providing some classes in the Java namespace, and we need this parameter here. So typically, you don't need to change anything in the in the Android build.gradle file. You do need to change things in the Android manifest file, which is here. What you change here is the name of the main class. In our case, we have a property Android name main class, and the value is org JavaFX ports hello world, hello Android. If you want a different application, you have to change this class name. Also, you probably want to change the label of the activity, which is hello Android FX, but you can change it to any label you want. And also the name of the application itself, which is here, hello Android. You can change it to whatever name you like to. If you want to, if your application is using more permissions than the standard ones, you just add them here in the permission sections. The Android manifest file is at the Android subdirectory src main Android manifest.xml, and you can modify it. The Gradle plugin will automatically pick it up and will put it in your binary application. So, as a summary, in this tutorial we showed how you can use NetBeans with the Gradle plugin to inspect the JavaFX Android project with the correct setup, and how you can leverage the source code between an Android project and a desktop project, which will of course make your debugging release cycle much faster. So you keep all the generic code in core, and the desktop project is typically used for running your application on a desktop before you want to run it on an Android device. That's it for now. I hope you enjoyed the tutorial and that you can continue working on JavaFX applications that will run on Android devices. Thanks.